to this year's Engine Week. It's time to learn all about engines in aviation.
Nick Otterbeck, Air IT Aircraft. We've been here since 2004.
Firewall forward components, radiators, cowlings, engine mounts.
This is based on several hundred Corvair-powered Zeniths that have flown over the years.
Thunderbolt is kind of its own animal for Lycoming.
Now it's Continental Titan, that's how they came together. Yeah.
And we're looking for service and support dealers currently.
This is our 160 horsepower, same family of engine as the 140.
So I just arrived here in Sebring, Florida, which is home of Lockwood Aviation Supply, which is pretty much your dealer for the Rotax for all the United States and North America. All right, so I wanted to introduce you all to Dean if you've never met Dean before. We're standing in a very nice part of Florida called Sebring, and just on the other side of this hangar is a very loud and noisy racetrack, which is awesome.
Stupid machines.
But, so if you hear some really crazy engines, it's not aircraft, and it's not Rotax, it's cars. So Dean, introduce yourself real quick. We'll do a little bit of a walk and talk and several of the projects you got going on here at Lockwood.
Okay. My name is Dean Vogel, for those who haven't met me before. Background was Air Force and Cirrus Design, and then coming to Florida and working here at Lockwood, helping to train people on Rotax aircraft engines and doing technical support for people that are operating with Rotax engines. Like Brian said, we're here at Sebring at the Lockwood facility. The hangar is always filled with airplanes of different sorts. We almost always have air cams in here, RB-12s, Technums, flight design, the works. Right now as a backdrop we're using the RV-9. This is a project that was done between Vans and Lockwood and Kodiak Research to be able to get a 915 or 916 into an RV-9. So that created quite a stir last year at Oshkosh, and we're working hard to try and get that into a firewall forward package so that people can enjoy an airplane like that. Those are some pretty impressive numbers with a Rotax engine in there.
So we're going to get into the engine discussion here in just a little bit, but since we're out here in the hangar, there's some cool things going on. I figured we'll talk Rotax installations and projects and then dive into the engines. All right, Dean, so you mentioned this project has been around for a little while, and I apologize, I somehow missed it. But if everybody could take notice to how long the nose is of this RV-9 that Dean is showcasing for us. It is not a jet engine, although you would think by looking at the front end of this thing that it is a jet. But what is going on with the Rotax and the RV-9?
Basically the idea behind this, once Rotax started in with the 915 and 916, that engine becomes a good replacement for an IO320 or an IO360 or something like that. Horsepower-wise, that's a good match. The problem is that the Rotax is a much lighter engine, so making that transition is not trivial. Vans, after they've got the injected engines into the RV-12, they recognize the advantages of the Rotax engines and the performance that they got on it from the RV-12. So they were pretty excited about the idea of being able to get some of the higher horsepower Rotax engines into the RV-9. The RV-9 being their design that has a little higher aspect ratio wing, a little better for high altitude cruise, so that makes a good matchup for the turbocharged engines. But again, putting those engines into an airplane where they're replacing a 320 or 360 does not become a trivial project because the engine is so much lighter. So yes, as Brian mentioned, you notice that the nose is significantly longer on the airplane because in order to maintain the CG, we've got to get it farther out. The challenge that happens though when you do that is now you've got significantly more sail area out here, and it starts messing with your lateral stability, so we've had to do a lot of work, like about 3 iterations to get this installation right, so all the airplane stability was where it needs to be. We're pretty happy with where we are right now. We, this past summer, pulled the 915 out. There's now a 916 in there. working through some of the issues and the differences between the two engines. And I wished I could put a timeline on it, but obviously the idea is for us to start providing a firewall forward package for the RV9. And we've got quite a few RV9 builders that are pretty excited about that coming available.
All right, so Dean, to not neglect literally the elephant in the room is this very tall aircraft on floats. You guys call it the AirCam, and
Correct.
It is specifically and only powered by a Rotax. I'll explain what the AirCam is and the horsepower options or Rotax options for it.
Okay. The name AirCam is just literally for air camera. It was designed specifically to have a platform for putting cameras in the air, and it has worked well for that. It was first done for some people that worked for National Geographic, and once people started seeing that in operation, they decided, I got to have one of those. So the airplane got redesigned so that it could be done reasonably as a kit. It was designed from the get-go for use with Rotax engines. It has been done with everything from 582s all the way up to 914s so far. I've seen a couple photographs of somebody that used an Edge performance on it, though we're strictly Rotax people ourselves. We have one customer that has a AirCam on amphibious floats like this, and he's got a pair of 914s with Airmaster propellers, so he can take off at 5,800 RPM, and he claims 3.5 seconds off the water, which sounds kind of amazing to me. But yeah, you've got a wide variety. The nice thing about the AirCam and the Rotax engines is when it's on conventional gear, we've actually loaded the airplane to gross weight, fired up one engine, taxied out, and took off that way. So the whole idea with the power to weight ratio and with the engines mounted as closely together as they are is you can be flying over terrain that you would never want to think about landing on to do camera work, and if you lost an engine, you would still be able to safely fly out of there without a great deal of challenge at all.
All right, Dean, since I had you climb this ladder here to talk engines, I just figured we'd point out the pusher configuration with the Rotax and what might be slightly different from a tractor, or if anything at all.
Okay, well, one obvious thing is when you're in a pusher configuration, you're not exactly worried about a spinner on the front because you're in the trash behind everything that's in front of it. In this particular installation, there's no cowling around the engine, so there's a lot of air over the cylinders. So cooling, at least as far as the cylinders is concerned, is a lot easier. Obviously, with the way the engine's mounted, the muffler comes behind the engine, so it's under the gearbox, whereas in most of the other installations you see, it'll be either back toward the rear of the mag end of the engine, or completely off the end of the engine. On the AirCam, they use a big automotive type radiator which gets air through the wing, so it's got a lot of radiator surface area there and gets the cooling that way. When we had the installations for the injected engines as opposed to the carbureted engines, we actually ended up needing to put an electric fan on the radiator there because sitting on the ground it doesn't get enough moving through that radiator to keep the injected engines cool while it's sitting on the ground. Now, it looks pretty cool. It looks like a flux capacitor sitting up there, but it does add weight to the airplane.
Okay, and then maybe the baby elephant in the room is, what in the world is this used for other than churning up air?
Okay, basically what it was this was a flight design CTSW that got damaged in shipping coming across. And so they replaced the fuselage on that particular airplane before it got delivered to the customer. But because we've got it, we have the ability to mount a 912 ULS on it, and so we will routinely use this for testing, for instance, for carburetors the customers send in. About once a month or so when we have engine classes, you've got anywhere from 12 to 18 people all over this engine doing oil changes and compression tests and friction torque tests and things like that, so they get a hands-on experience for the kinds of things they would do during a normal 100-hour condition inspection.
So you basically got an inexpensive engine stand in the shape of an airplane.
There you go. And it's easy to wheel around, and it's easy to chock and lock the brakes on it so it doesn't go anywhere. We take it out and we do carburetor synchronization on it, and so that people actually get to see how that all works and how important it is to synchronize the carburetors on the carbureted end.
I just want to pop in real quick and invite you all to our 31-day build challenge, which starts in December 1st through the 31st, which is why the 31 days. Every day is an opportunity to get something done on your aircraft, even if it's something very small like reading plans or setting out something for the next day. The idea is everybody has their end of year, New Year's resolution, and this is kind of a way to get started very early in December. And amongst other builders, they're doing the same thing. So I invite you to post some, we prefer video, but definitely photos of what you got going on in your hangar or your home workshop or even at your kitchen counter. Share with everybody what you got going on the Experimental Aircraft Channel group. That's on Facebook. Just search Experimental Aircraft Channel and groups. That should pop right up. And join us for the 31-day build challenge. And also, let's take a moment right now to thank our sponsors. Dynon Avionics at Dynon.com, the premier provider of glass panel avionics systems for experimental and light sport aircraft. And visit our website at experimentalaircraftchannel.com for new videos and easy to navigate playlists and so much more. Dean, so moving up to the classroom, and then we'll get into the specifics of the engine, just to kind of showcase things that go on here at Lockwood. You do offer classes here, and you want to explain just a little bit in brief what goes on here during those classes?
Basically about 12 times a year, we do classes in here. We don't schedule in July or December for obvious reasons, but yeah, we'll have anywhere from 10 to 18 people in here at a time. There's a 2-day service class where we teach people how the engines are unique compared to traditional aircraft engines, and what that means for the care and feeding of the engines, and basic condition inspections. And then there's a 2-day maintenance class where we go into some of the disassembly of the components off the engine. Let's say, for instance, somebody had a sticking valve. They would know how to get the head off, send it to a heavy maintenance repair facility, get it back on the engine, and get it up and running again. And then we also have a specialized class just for the injected engines and the systems that have to be on the airplane to support that engine, and some basics on the inspections and how to do repair on those as well.
How about we walk through the different models that Rotax is still offering, and correct me if I'm wrong, the base years ago and still available today was the 80 horse is the bottom line, and then moving up from there, correct?
That is correct. It was, I believe, 3 years ago at Oshkosh that Rotax announced the end of the last 2-stroke engine for aviation applications. So the base model engine is the 80 horse, and that's a carbureted engine, 1211 cc, 9-to-1 compression ratio. The turbocharged version of that engine is the 914, 115 horse for takeoff, limited to 5 minutes. Then you've got the ULS or the S, which is slightly bigger displacement, 1352 cc, 10.8 to 1 compression ratio. So they achieved 100 horsepower with that. This is the one that is the most ubiquitous at this point out there in the field on a lot of the applications. 2012, they came out with the injected version of that same displacement engine. Then in 2017, they brought out the turbocharged version of that engine. They reduced the compression ratio a little bit and added boost at sea level to get to the 141 horsepower. And then, let's see, this past spring they came out with the 916 and obviously increased the boost even more. So now it's 160 horsepower for takeoff.
Okay, so staying on topic of just the carbureted models here for a second, as far as maintenance is concerned, most of the platform Rotax are very similar, but talking specific to the carbureted ones, the two things that I hear the most chatter online about is synchronizing the carburetors, and then also something to do with the gearbox and the clutches or something like that, keeping that with certain torque. Can you speak to that for a minute on those two items?
Certainly, yeah.
Why they're so important.
And you'll see these items that you're asking about right in the inspection checklist or the maintenance schedule for the engine. Basically at every 100-hour condition inspection, you're going to be checking the synchronization of the carburetors. It just involves hooking up a pair of vacuum gauges and running the engine. It's not a trivial process. It takes me about 2 hours to teach people how to do that in the engine class. But once you see what the engine starts off like when it's not synchronized and the way it runs after you do get it synchronized, you understand exactly why it is so important to do it. And a lot of it has to do with the wear and tear that happens on the gearbox as well. The gearbox has a scheduled maintenance, and basically that's currently about 1,000 hours. If you've got a gearbox with what's called a 30-degree dog, and we won't have time to explain that today, but if it has one of those, you have the ability to lock the crankshaft and do a check on that dog at your 100-hour condition inspections to make sure that the spring discs in the gearbox itself are still in good condition. Regardless of how that turns out, at least by 1,000 hours and the gearbox comes off, goes in for an inspection at a heavy maintenance repair facility, and then you have the ability to get it back on there and get the airplane up and going again. As long as someone has learned how to do the synchronization, how to set up the engine, there's very little other maintenance that needs to be done on the gearbox, and it works out quite well.
Okay, Dean, jumping from the carburation over to the fuel injection conversation, what has really changed in that jump?
Oh man. About the only thing that stayed the same was the displacement and the compression ratio.
Okay.
It's still 1352 cc, it's still 10.8 to 1 compression ratio, but well, and it's the same gearbox other than the fact that it's a 0-degree dog versus a 30-degree dog on the 100-horse engine. But other than that, almost everything else changed on the engine. All the ignition changed, all the induction changed, the engine controls changed. Where do I begin? You've got dual fuel injectors for each one of the cylinders, just like you have dual spark plugs. The EGT is now standard because the ECU, the engine control unit, does monitor the EGT on the engines. You've now got a throttle body, okay, that is controlled in the traditional way with a throttle from the cockpit, but now you've got airbox pressure and temperature sensors that the ECU monitors, and obviously dual channels. So there are 2 computers in the ECU, either one of which can run the engine. So you've got your redundancy there. You've got a stator inside the ignition housing on the engine with 2 coils on it. And on the fuse box, which controls all the electrical power for the EMS, the engine management system. The engine can run off of either one of those regulator rectifiers on the fuse box to provide power for that. In normal operation, one of them is used to power the airplane. Should the primary regulator, I'll just call it regulator because that's what Rotax is starting to call it in the manuals, even though it's a regulator rectifier. But if the primary regulator fails, then the fuse box goes to the backup and it takes it away from the airplane. Otherwise, that one would be providing about 30 amps capable of power to the aircraft itself.
Now, is that their internal, is that dry or is that actually wet?
That is wet. That is wet. They wanted to run enough amperage now through the coil for the power that they needed to pull it inside so they could spray oil on it to keep it cool. And what it does is it puts out on 3 pins on these connectors, it literally puts out 3-phase AC power, and then the regulator rectifier rectifies it to DC, regulates it to 13.9 volts, and then provides that either for the EMS or for the aircraft.
So one question I ask a lot when we're talking about these modern engines with fuel injection and computers and so forth, can this run without a battery or an alternator or both once it is started? In other words, does it generate?
Once it is started, it's independent of the aircraft. Okay, primary mode, the regulators on the fuse box are called regulator A and regulator B. It runs primarily with regulator A running the EMS, regulator B providing power to the airplane. In backup mode, should regulator A fail, then the fuse box takes regulator B away from the airplane and uses it to run the EMS. Now, should regulator B subsequently fail, the first thing you know is you weren't supposed to be flying today, because the idea both of them would fail on the same flight is pretty remote. But should regulator B subsequently fail, then the engine will shut down because there's no power running the EMS. But then standard setup of the airplane is there will be what's called a battery backup switch or an EMS backup switch that you throw that, and it provides aircraft power now to the fuse box. And so now you can fire up the engine and it runs, but now the EMS is running off of the battery. So you've got a limited time to get the airplane on the ground now while it's running on battery power.
All right, Dean, let's talk fuels for just a minute. I get this question a lot of all kinds of engines. Avgas versus MoGas versus car gas. What is to be used and what's okay to use and so forth? Is there anything to help use a specific fuel?
The engines were designed to run on automotive type fuels. Okay, they'll run just fine on 100 low lead. Now, the lead becomes an issue because it gets on the exhaust valves and the combustion chambers and stuff like that. A couple of things you can do to help with that is if possible, cruise above 5,000 RPM. That keeps surfaces hotter and you have less lead deposits showing up. You can't do that with all airplanes. You can't do that in an air cam, for instance, okay? But with what airplanes you want to run above 5,000 RPM if you're running 100 low lead. The other thing about 100 low lead is your oil and filter changes are going to come a lot more frequent because you're going to be getting a lot of that into the lead, and you're going to want to be cleaning the oil tank every time because you'll have a lot of lead showing up there. One of the other things you can do to help yourself with 100 low lead use is use some form of tricresyl phosphate. One example would be the use of Declan Run-Up. Okay, tricresyl phosphate, what that does is it causes the tetraethyl lead to combust into lead phosphate rather than lead oxide. Lead oxide gloms itself onto the components in the engine and ends up in the oil, whereas lead phosphate is a powder and most of that just blows out the exhaust and goes away. So that helps a lot if you're running 100 low lead. Our favorite fuel at this point is Swift. We've got a 500-gallon tank of it. Any of the airplanes that we operate here at Lockwood, we've been operating exclusively on that for like 8 years now, and it's beautiful. It's basically, they call it 94UL. It's basically the exact same thing as 100 low lead, except without the tetraethyl lead. So you've got the stability of that fuel without the worry of what the lead deposits are going to do. Now, Swift is not available everywhere. You can go to flyunleaded.com and find the airports where it is available and maybe plan your cross country such that you can hit those airports. But you can also use an automotive fuel in these engines. For most of the engines, it's a minimum of 91 AKI fuel. So a lot of people will use like 93 rec fuel or something like that. That works just fine. You want to try, if you're using automotive fuels, a couple of key items is you want to use reputable fuel blenders. You know, like a Sunoco or a Shell would be fine. I would not be buying my fuel from Circle K or Racetrack and put it into an aircraft engine. And for a couple of reasons. One is the stability of the fuel, particularly on the carbureted engines. You've got fuel sitting in the carburetors, and if the fuel is not stable, the more volatile distillates flash off. When their solvent quality is gone, the baser distillates precipitate out in the form of goo or varnish, and that makes a mess of your carburetors. Now that's a little bit less of a worry on the injected engines, but it can still go bad. Now the other thing that has become quite an issue with the automotive fuels is the Reed vapor pressure. You might recognize that as talking about winter blend fuels versus summer blend fuels. People get in a lot of trouble when they've got a winter blend fuel still sitting in the airplane when the weather gets warm, and now that fuel vaporizes very easily. So when your mechanical fuel pump on the carbureted engines is operating and pulling from a tank that's well aft, especially under acceleration or climb, then you start ending up forming bubbles and vapor in the fuel line. Depending upon where you put the electric fuel pumps for the injected engines, that can be a factor too. Personally, I like to see those pumps behind and below the fuel tanks if at all possible. If you're having to draw fuel from aft forward to that pump, you get some of the same vaporization issues going on. So Reed vapor pressure has become quite an issue for us to watch for in these airplanes now.
All right, so I just want to jump in with Dean here real quick and talk about this engine. If you guys have been following the channel for any length of time, I kind of tasted all the engines to a degree. I had one specifically built for me, which is an old Franklin. I took a couple different routes, and I landed on this particular model you see right here, which is the bare bones basic ULS with the carburation, just to keep it simple and absolutely the lightest option I could get. But through that, I got it through a third party used, and very low time. It was like, I think 240 hours, and come to find out, I had it inspected by a Rotax center, and we talked earlier about the dogs inside the gearbox, and they were chewed up, or what you would call pocketing.
Pocketing, right.
Okay.
Right.
And then we talk off camera for a minute about the reasons how that can happen. One is synchronized carburetors could be off. You know, make sure that's taken care of. Two, just the washer's called?
The washers are spring discs, okay, that are inside the gearbox.
They could be bad, but more importantly than that is simply the operation of your engine and RPM. So could you explain, because I just learned something here today that I'm going to save to my memory bank for future.
He needs repetition.
I do, and to burn it in there. So what is a proper way to operate this engine so that does not happen, and it usually is on the ground?
When it comes to idle speeds, there's something of a sweet spot at 1800 RPM. If you set the idle above 1800 RPM, what you're doing is you're disabling the starting carburetor for cold weather start on the carburetors. You don't want to do that. Okay? If you go below 1800 RPM, you could be introducing more wear and tear on the gearbox. Now, operationally, if you set this so that the idle is normally at 1800 RPM, it's still producing a significant amount of thrust. And most light sport aircraft are light enough, small enough, slick enough, that can make it difficult to get the airplane on the ground in a graceful fashion.
Just a few hundred RPM.
Right, exactly. And so basically you don't want to do that. Typically you want to set the idle down around 1550, maybe 1600 RPM, something like that. But now as a result of that, that will be the RPM when you're sitting on the ground.
And just to clarify, when you say set that, you mean the stop. In other words, you pull all the way back, it doesn't drop below that. Not you personally setting it, but an idle stop.
The idle stop on the engine itself, right. If you set that so that when you're on the ground, you pull it to idle, it goes to 1550, 1600 RPM, okay, that's a good thing for operations in the air, but on the ground, you don't want the engine running down that low because it's going to introduce a lot of wear and tear on the gearbox. If we were to go outside and run an engine and I showed you what it sounded like at that idle versus 2000 RPM, you'd actually be listening to the gearbox.
You'd hear the chatter somewhat.
You'd hear that chatter in the gearbox, exactly right.
So your suggestion is to run it at what RPM when you're idling?
Well, yeah, when you're sitting on the ground, bump the throttle up, 2000, 2200 RPM. Something in there, and then that noise goes away, and you know you're not putting that wear and tear on the gearbox. If you want to pull it to idle while you're going down the taxiway to save on your brake pads, okay, that's understandable, but when you're sitting in the chocks, or you're sitting at the end of the runway doing your pre-flight, or waiting for clearance to get on the runway, or whatever, 2000, 2200 RPM.
Good to know, good to know. So not necessarily a tech tip, but more of an operational tip to operate this.
Actually kind of both, but yes, yes, exactly right. And he's got experience on how expensive it is to get the gearbox back in shape when that pocketing happens. So, yeah.
Yeah, lessons learned. It was not my doing, but lessons learned. You don't know what you get, even on a low time engine that looks good. You've seen video of it running good and this and that. That's why it's always good to have somebody check it out to see, is it good?
Right.
All right, Dean, well, thanks for giving us the tour around Lockwood and with all the projects going on and some engine talk. Where can everybody get in touch with you specifically to line up if they want to come to one of these classes to learn more?
If you go to lockwood.aero and then click on training, you'll see all the dates that we have scheduled for the various classes. If you have questions on what the classes are, you can call us here, 863-655-5100. Alternately, you can email me. It's just dean@lockwood.aero. That's AERO, like aerodynamic. Get it? Okay. And no .com, just dean@lockwood.aero.
Outtakes, we can do outtakes all day long.
Ready, now.
So Dean, I apologize. You mentioned, Dean, how about we just walk through the different models that Zenith. I'm recording, but it's not a moving target.